Good evening. So let's try some fun stuff with physics. One of the great confusion for students, at least for me, was that in the conservation of energy principle, how to choose a system. So I'm trying to demonstrate something that deals with that problem. I don't have a dumbbell in my room, so I like Swiss rolls, so I'll experiment with the Swiss roll box. I initially have a Swiss roll in my hand, then I lift the Swiss roll up slowly. So it goes up. So initial velocity is 0, then finally it goes up. It attains a height h, and there's a final velocity bf. So how do we write the conservation of energy here, or how do we write the energy equation? Well, there are different ways we can do that depending on the system that we choose. Now, let's describe what those different ways are by choosing system. So let's say our first system is the box itself, right? So in our energy principle, delta E equals W. That means E energy final equals energy initial plus W. So what are the energy final? Well, the energy final is the kinetic energy associated with the box, which is half mvf squared, because there's a velocity associated with the box going up. Initial kinetic energy of box is 0. Why? Because there is no free velocity. It's initially at rest in my hand. And what about the work done? Well, since the only system we have is the box itself, there are two forces acting. Force by me, F upwards, and the force by Earth downwards. My force will displace the object by height h. Therefore, work done will be F dot h. mg is pulling down. So the work done will be force times dot displacement, which is mg dot h. Displacement from the rest to height h. So in that case, our energy equation will look something like that. Half mv squared kf equals ki is initially 0. Work done is by me and the Earth, which is F dot h minus mg dot h. Now, this is not the only way we can do it. What if someone chooses a system as the box and the Earth itself? Now, the same energy equation, one thing will be different. What will be different? Not only we have a final kinetic energy of the box, but we also have a potential energy of the Earth. Now, why? Because Earth is a part of a system now. There's interaction going on. So the Earth has a potential energy. And what is that final potential energy? mg dot y, or h, then height h covered. So then, but our initial kinetic energy is 0. Also, our initial potential energy is 0. Why? Because there is no displacement. So mg y is 0. Delta y is 0. Now, what about the work done? Okay, let's say our Earth is a part of a system, right? Box. So the work done is 0? No, that's where I got confused. But actually, it's not 0. Why? Because even though the Earth is a part of a system, I am the external force that's pushing it upward, with, say, force F. Then in that case, the total work done outside will be F dot h, not 0. Considering all those cases, what does our energy equation look like? This. Half mv squared kf plus potential energy due to Earth mgh equals the work done by me, F dot h. Now the third and final case is, I'm part of system, Earth is part of system, everything. Swiss roll box is a part of system. What is our energy equation look like? We have kinetic energy final of the box, potential energy final of the Earth, energy due to me. Well, even though it's not too heavy, I'm pretty sure I'm losing some kind of energy or some kind of chemical energy lifting it up. And then our initial kinetic energy is 0, initial potential energy due to Earth is 0. I have some initial energy from my body. Then in this case, what happens? Something is 0. What? Work done is 0. Why? Because since I'm the part of the system, Earth is a system, this is also a part of the system, there is no external force doing some kind of work. So having said that, our energy principle, our equation will look something like this. We'll have kinetic energy final, potential energy due to Earth final, energy due to me, kinetic energy initial is 0 because initially it's in my hand at rest, potential energy due to Earth initial is 0 because there is no displacement, and energy due to me initial, work done. This is the most important part because everything is a part of the system. There is no external force, significant external force acting. There is no external work done. So work done will be 0. Now, so after describing the different way that we can choose a system, let's go back and do a problem. But I'm not going to do the problem related to lifting something. Let's do a problem associated with a spring, because a spring, and choose different system so that we can solve the problem. Anyway, so let me change this backwards so that I can explain the problem, and it's not letting me change it backwards. How do I change it backwards? Alright, I will do it in the following video.